Alright, so we have this problem. In the figure below, well, in the figure to the right I should say, determine the point other than infinity at which the total electric field is 0 meters to the left of the negative 2.5 microcoulomb charge. Alright, so we got the figure. We've got the negative 2.5 microcoulomb charge, and then to the right of that we've got a 6 microcoulomb charge, and it's separated by 1 meter. So we know that somewhere to the left we're going to have somewhere the total electric field is going to be equal to 0. So E is going to be equal to 0. So how would we figure this out? What's the intuition behind solving this problem? The best analogy I can use for this would be to look at it in terms of work. We've got a negative 2.5 microcoulomb charge, and it's going to be pulling, there's going to be a force directed inward. And we've got a 6 microcoulomb charge that's going to have a force pushing this way. And we need to find the distance at which this point where the positive charge pushing to the left and the negative charge pulling to the right are going to be the same magnitude, so that there is no electric field. And so to kind of look at it a different way, imagine you've got two people. So you've got Bob over here, and Bob is negative. He is always having a bad day. You've got Mike, who's positive. He likes to look at things optimistically. Now, what they're going to be doing is they're going to be pushing on a box. And to make the work being done equal to 0, what you're going to have to find, what you would have to find, is that Bob has to be pushing with the same force as Mike, so that the box is stationary and it does not move. So these are going to have to both be, so that the magnitude of Bob is going to have to equal the magnitude of Mike, so that there is no work being done. And it's the same concept right here, except for electric fields, the only the charges are set. The only thing we can manipulate is the distance. Alright, so we set the problem up. We say we know that E, or the electric field, is going to equal K over Q by R squared. And so we've got E over here, and we've got another E. And what we need to do, just like this, so you've got Bob, let's say you've got the force being done by Bob, and how you make it equal to 0 is you make them equal to each other. You say the force being done by Mike. Same thing here. We're going to say the E of the negative is going to equal the E of the positive. So we set this problem up and we say K over 2.5 microcoulombs over the distance squared is going to equal K over this 6 microcoulomb charge over the distance squared. So this is what we know so far how to solve the problem, but how do we know what to put for the distance? Well, that's not too hard. Let's imagine this imaginary point, and it's going to be somewhere between, for this 2.5 charge, it's going to be somewhere between this 2.5 charge, okay, and this imaginary point. And we're going to call that x because we don't know what it is. So we're going to put down here, we're going to put x. And remember, because of this formula, it's going to be x squared. Alright. And we know that from this 6 microcoulomb charge right here, the 6 microcoulomb charge to right here is 1 meter. And we know from this negative 2.5 microcoulomb charge to this mystery x value is going to be x. So for the distance, it's going to be x plus 1 meter. So we're going to say x plus 1 squared. Now all we need to do is do a little bit of algebra. So the first thing we do is we're going to cancel off those k's, because if you were to divide a k right here, cancel that out, right here, it's canceled out. Alright, so we're left with 2.5 microcoulombs over x squared equals 6 microcoulombs over x plus 1 squared. So then we just simply rearrange this problem, and we say 2.5 microcoulombs over, and here's what we're going to do. We're going to take this 6, we're going to throw it down here, we're going to take this x squared, and we're going to put it up here. So we say 2.5 microcoulombs over 6 microcoulombs is going to give us x squared over x plus 1 squared. Well, then we can square root it. So we square root it, square root both sides, and that's going to give us the square root of 2.5 microcoulombs over 6 microcoulombs equals x over x plus 1. Alright, so when we square that, when we square the 2.5 over the 6, we're going to be left with alright, so we square that, and we're going to be left with a 0.6455 is going to equal x over x plus 1. So then we take this, let's throw this x plus 1, we're going to bring it up here. So then we've got 0.6455 over x, times x plus 1 equals x. So we get a 0.6455 x plus a 0.6455, so we multiply, equals x. So then we're going to subtract this 0.6455x from this 1x. So we've got 0.6455 equals a 1x minus a 0.6455x. And that's going to leave us with 0.3545x. So now we've got this 0.6455 equals 0.3545x. So then to solve for x, we're just going to take this 0.3545 and we're going to throw it under here. So then we've got .6455 divided by 0.3545 equals x. And when you do that, you're going to get x equals 1.8 meters. And so we know that for this electric field, the total electric field to equal 0, this mystery point is going to be 1.8 meters to the left. So it's going to be 1.8 meters to the left of this negative 2.5 Coulomb charge. And that is how you solve that problem.